equal to 0.52%. This is our percentage of steel. This is our percentage of steel. It is equal to 0.52%. And what is the reinforcement at top? At top, what we have provided? At top, how many bars of which diameter?
3 bars of 20 mm dia.
Okay, so 3 bars of 20 mm diameter. This is our top reinforcement. And at bottom, what is the reinforcement at bottom?
Same.
Same. Okay, 3 bars of 20 mm diameter. So these are our reinforcement details now. Now the next step is we will take the check for shear. आपण डेप्थला चेक घेतलाय का आपण? मला एक सांगा आधी बेंडिंग मोमेंट कॅल्क्युलेट केल्यावर.
Yes, sir.
Have we checked the depth after the bending moment calculation?
Yes, sir.
Okay. So now we will go for the next step. Now this is our top and bottom reinforcement. At top we are going to provide 3 bars of 20 mm. At bottom also we are going to provide the same reinforcement. Now we will see that the shear reinforcement. Okay. So now we need to calculate the check for shear. So I will give the heading here. Shear reinforcement. Shear reinforcement. Okay. So first of all, calculate the shear force. Okay. First we need to calculate the shear force, maximum shear force, BU. We need to calculate the maximum shear force. So how do we calculate the maximum shear force? The maximum shear force can be calculated. Now this is the case of continuous beam. So we need to design the continuous beam same as that of the continuous slab. So what we do in the continuous beam? We will move to the page number 36, table number 13, and from there we will take the coefficient for shear force, and from those coefficients we will calculate the maximum shear force. Okay, so for that purpose now we will move to our IS code. Okay, so in IS code now, page number 36. Okay, table number 12. Page number 36, table number 12. Now this is the table. You can see over here. This is the table. So again, this is the table for shear coefficient. Shear coefficient, table number 13. So these values, this table we have already used while calculating the shear force for one-way continuous slab. Same we need to do, and we are having some coefficients over here. Okay, so where the shear force is maximum, see the coefficient. This is for dead load, and imposed load means this is live load. Dead load and live load. So at support, dead load coefficient is 0.4, live load coefficient is 0.45. So if you see at dead load coefficient is 0.4, for live load coefficient is 0.45 at the end support. Then at support, next to end support, the coefficient is 0.6, dead load and live load coefficient is 0.6. Okay, we don't take this inner side, we always go for outer side. 0.6, 0.6, and there is not much more difference in inner and outer also. So, and at all other interior supports, it is 0.5 for dead load, 0.6 for live load. Okay, so if you see, how do we get the maximum shear force? The shear force is maximum where the value of this coefficient is maximum, because for obtaining the shear force the coefficient shall be multiplied by the total design load. Total design load means what? W into L. Okay, W into L is nothing but your total design load. So W into L means W dead load into length and live load into length. Okay, so dead load is in kilonewton per meter, live load is also in kilonewton per meter. So if you multiply it by length, then you will get the design load. Okay, so the maximum coefficient is this one. These two are the maximum coefficients for dead load and live load. Okay, so 0.6, 0.6, both the values are 0.6. So when the coefficients are 0.6, then we will get the maximum value of this, what we can say, shear force. Okay, so we will move to the problem now. 0.6 is the coefficient, so remember this. Okay, so Vu is equal to, so the coefficients are 0.6 for dead load, so 0.6 into WUD, it is for dead load, into L effective plus plus 0.6 into WUL live load into L effective. Now if you solve this, you will get the value of Vu. So Vu is equal to, it is 0.6 into, what was the value of dead load? What we have calculated? What was our value of dead load? Let me know the value of dead load and effective span. We have already calculated total dead load, total live load. Dead load is 22.2, I think. Is it correct? Okay, dead
Yes,
load is
sir.
22.2 and live load,
18.
okay,
18.
18 is the live load. And what was the effective span?
6.
6. Okay, so multiplied by 6 plus 0.6 into 18 into 6. So now solve this, so we will get the maximum value of shear force. So 144.72 is the answer. Others please check it. Okay, 144.27, 72. Okay. Okay. You are share this answer in the chat to all, so that others will also confirm the answers. Okay. So while messaging in the chat, you do the message to everyone, so that the answer will get confirmed. So now it is 144.72 kilonewton. So this is our value of shear force, 144.72 kilonewton. Now after the calculation of this value, now we will going to calculate nominal shear stress. So after the calculation of shear force, we will calculate nominal shear stress. So nominal shear stress is nothing but it is called as tau v notation, which is equal to Vu upon Vd. So if you put the values, you will get the answer. So your shear force is 144.72. It is kilonewton. So multiplied by 10 raised to 3 divided by V into D. So we have assumed our width as a 300 into, what was our depth? Depth to किती होती आपली effective depth? What was our effective depth? Let me know the effective depth.
600.
किती?
600.
600.
So,
So 600. So now calculate tau v. It is 0.804. It is 0.804. What is the unit? Newton per mm square. Okay, that is nothing but megapascal. Newton per mm square is nothing but it is megapascal. Okay, wait for 1 minute. 144.72. This coefficient 0.6. These coefficients are at the support which is next to end support. So now these coefficients 0.6 are there at these points. Okay, now if I show you with different color, then at this point those coefficients are there, and the value of VU is 144.72 at these supports. 144.72. So this is your VU max. Here you have calculated the value of VU at these 2 points. Okay. So now, what is the percentage of steel provided at this point? That we need to calculate. Okay. So we have already calculated that, but we need to put that value now because we have calculated the shear force at this point. So this point, the name of this point is support. This is the support which is next to end support. Next to end support. This is the support which is next to end support. So at this support now, what was our percentage of steel? So you see the negative moment. In the all those negative moments, we have calculated one moment which is at this point, and the percentage of steel for that moment we have calculated that percentage of steel as 0.52%. This is our percentage of steel at this point. Okay, this is our percentage of steel. So the meaning of this is, again if I show you by another diagram, suppose now this is the diagram, and if we draw the bending moment, now I will not draw the, okay, I will draw the supports for your better understanding. Here second support, third support, fourth support. Okay, so now here at this point now the bending moment diagram will be like this, and it is continued. Okay, so now if you see, the percentage of steel is nothing, it is for this moment. This is your moment. Okay, and for this moment the percentage of steel is 0.52%, and the value of this moment we have already calculated, it is 151 point something, which we have already calculated previously. Okay, so we got at the same point the value of maximum shear force. So now what we needs to do, we should find out. Now we are knowing the percentage of steel now. So percentage of steel, it is 0.52%. So from the percentage of steel now we are going to find out the permissible shear stress. Okay, so permissible shear stress, tau c, that we need to calculate. Okay, permissible shear stress. So from where we are going to calculate permissible shear stress? Table number 19. Okay, we are going to use the table number 19. So now we will move to that, need to go to table number 90. So for that, but 90, table number is 90. So this is table number 19. Okay, design shear strength of concrete. So here, what is our percentage steel now? So our percentage of steel is 0.52. So M20 is the grade of concrete. So here for 0.50. Okay, so here point for 0.50, the value of M20 is 0.48. Okay, and we want the value for 0.52. So interpolate between these two values. Okay, interpolate between these two values. So you will get the answer, and let me know the value of tau c. Calculate the value by the interpolation and let me know the answer. So here we can say that for point 0.5, what is the value? Value is 0.48, and for 0.75, for 0.75 the value is 0.56. Okay, now we want what was the value for 0.52. So simple interpolation is there. So do it and let me know the answer. This 0.84864. So we will take it as a 0.49. So the answer is 0.49. Is it the correct answer? Let's check the value. So now try to send the message to everybody. Now I have changed the setting. Okay, so answer is correct. Okay, so we will move forward. 0.49 answer is correct. So we will go to our whiteboard. Okay, so the value of tau c. Just now we have calculated this. The tau c is equal to 0.49 Newton per mm square. This is the value of tau c. And what was the value of tau b? Tau b is 0.8 and tau c is 0.49. So what is the meaning of this? So the nominal shear stress means what? The shear stress which is actually generated in that structure or in this continuous beam, that produced shear stress due to the loading is 0.8 Newton per mm square, 0.804 Newton per mm square. म्हणजे डेव्हलप व्हायला लागलेला आहे 0.804. And the capacity of beam or the permissible shear stress the beam can resist is 0.49. So beam can resist up to the 0.49 Newton per mm square. But developed shear force is much more greater than this. So we need to provide the shear reinforcement to counteract the extra shear stress. Okay, so here I can write now tau v is greater than tau c means what? So reinforcement shear reinforcement is required. The meaning of this is shear reinforcement is required. Okay, so if you finished up to this point, I will switch on to the next. Is it complete? Have you completed? The next thing is, so now calculate the shear resisted by concrete. So shear resisted by concrete. So we call this as VUC. So we are going to calculate the shear force. So force is nothing but stress into area, the basic formula. So the stress is tau c, permissible shear stress, and area is B into D. So just put the values, you will get the answers. So tau c, what was the value of tau c? Tau c is 0.49, B is 300, and our effective depth is 600. Okay, so therefore VUC is equal to, now do this calculation and let me know the answer. What is the answer? Do the calculation fast. Have you dropped? It is 88,200. Okay, so it is 88,200. So I will write here 88.2 into 10 raised to 3 Newton, or we can say this, it is 88.2 kilonewton. Okay. Now after the calculation of this shear resisted by concrete, now calculate unbalanced shear. Okay. So now we are going to calculate unbalanced shear force. So unbalanced shear force, we are going to use the notation VUS. So it can be calculated as VU, that is total shear force, minus shear resisted by concrete. So therefore VUS, that is unbalanced shear force, is equal to, what was our original shear force? It is 144.72 minus, now shear resisted by concrete, it is 88.2. So if you do this calculation, you will get the value of unbalanced shear. So let me know the answer. What is the answer? 56.52. Okay, correct answer. 56.52 kilonewton. So this is our unbalanced shear. Okay, so 56.52. This is our unbalanced shear. So now we have to provide the shear reinforcement for this unbalanced shear. Okay, so if you completed up to this point, let me know, so I will switch on to the next point. So we need to make one correction over here, so I will tell you that here now we got tau is greater than tau c, so the shear reinforcement is required, correct? Okay, so here this table number 19, this table number 19 is for slab. Sorry, by mistake we have used it. We have to use the table number 23. Okay, for beams we are going to use the table number 23. Okay, so now we have to do this calculation again for table number 23. Okay, calculate this value by using table number 23. Now we will go to the IS code. Here, so here you can see this. If I show you the permissible shear stress in the concrete in beam without shear reinforcement is given in table number 23. Okay, so now we have not provided the shear reinforcement, but by using this table now we are going to provide the shear reinforcement. And with shear reinforcement, if you see here, these are the maximum stresses in the beam. These are the maximum stresses in the beam when the shear reinforcement is there. That is the extreme value of tau c max. Okay, beyond that value, it should not, the stress should not get developed. So maximum value of tau c max over here is, you can see it is 1.8. Okay, so this is the maximum value. So now if we move to the above table, this is the table. So now permissible shear stress for beam, now we are going to take it from this table. So what is the permissible stress now? If you see, so for 0.5, the value for M20 is 0.30. Okay, 0.75, the value is 0.35. So we want the value for 0.52. So calculate the value for 0.52 now from this table. 0.30 and 0.35, 0.50 and 0.75. So calculate these values. So here, if you see 0.304, okay, so the value is tau c value, it is 0.304. So the value is 0.304. This is the value. Now based on this value, calculate this tau shear resisted by concrete. Now based on this value 0.34, calculate the shear resisted by concrete. It is 61200. Is it right? 61.2 kilonewton. This answer is right or what? This is the right answer. Okay. So now let me know the unbalanced shear now. Unbalanced shear is total shear force minus shear resisted by concrete. So it is 83.52. This might be the answer. Okay, correct. 83.52. Now for this shear reinforce, so this is now our unbalanced shear. Okay. So now this is our unbalanced shear. Now for this shear, now we are going to provide the shear reinforcement. Okay. So to provide the shear reinforcement now, here we are going to provide two-legged stirrups. Provide two-legged, okay, provide two-legged 8 mm 8 mm diameter stirrups. These are the two-legged stirrups. Now calculate the area of stirrup. So ASB is equal to, ASB is equal to 2 into 5 by 4 into 8 square. So what is the answer? Now this is area of transverse reinforcement. Answer. So it is 100.53 mm square. Correct. So it is 100.53 mm square. So this is the area of what we can say transverse reinforcement. Now we need to calculate the spacing for the same. So for the spacing, three criteria are there. So we are going to use those criteria. So for spacing, you can go for clause number 40.4, page number 73. So clause number 40.4, page number 73 from IS code. So we will go there first. In the IS code, that is page number 73. So we will go to the page number 73, clause number 40.4. Page number 73. So now this is page number 73 and clause number 40.4. Okay. So here here the formula is given. I will show you. So this is the formula just for the spacing of vertical stirrups. This formula we are going to use to calculate the formula for to calculate the shear reinforcement. Okay. So what is the formula? I will read it for you. VUS. VUS means unbalanced shear. VUS is equal to 0.87 FY ASVD divided by SV. So for the meaning of each and every term is given over here. You see ASV is equal to total cross-sectional area of stirrups. Okay. Then SV is equal to spacing of the stirrups. Then here the B is nothing but your breadth of the member. Tau C already know the permissible shear strength. Then tau V is the nominal shear stress. So Fy characteristic strength of the stirrups. Then D is the effective depth. So this formula we need to use. Where it is given on page number 73. Remember this. And this is clause number 40.4. Okay, so this is clause number 40.4. Clause number 40.4a. Page number 73. This formula is given. Okay, so write it down. It is important. So that there is no need to by heart the formula. It is there in IS code. So now we will again move to our slide board. So here now spacing of stirrups. I will give the heading spacing of transverse reinforcement. Transverse reinforcement. Okay. Means what we need to space the stirrups. Okay. So the first criteria. Okay, so spacing is equal to the first criteria spacing, that is SV, is equal to. So the spacing is equal to, what is the formula then? 0.87 Fy ASV into divided by VUS. Okay. So therefore SB is equal to, therefore spacing SB is equal to, it is 0.87 into Fy is 415 into ASB 100.53, we have already calculated, into D, our effective depth is 600. Okay, then whole divided by VUS. What was the value of VUS we have calculated? क्या ली थी value? VUS, I think previously we have calculated that value.
83.52.
Okay, it is 83.52. It is
83.52.
into 10 raised to 3. It is in kilonewton, so convert it into Newton. Therefore, spacing S which value सांगा किती आली?
260.75.
460.75. 60.74. So always we reduce the spacing. Okay, so we will reduce the spacing to 250 mm center to center. So from the first criteria, we got the spacing as 250 mm. Okay, this is from first criteria, we got the spacing. Similarly, we are going to calculate the spacing from the second criteria. And what was the second criteria says? This formula will remain same. Okay, this formula will remain same. Only from this formula we have to remove this D. Effective depth is removed, and instead of VS we have to VUS we should take 0.4 B. Instead of VUS we are going to take 0.4 B. Okay, so I will tell you how it is. Now here the formula is, so second criteria spacing SV is equal to, that is 0.87 into Fy into ASV, okay, ASV, and at the denominator it is 0.4 B, 0.4 B. So put the values and let me know the answer. We will get the answer. 0.87 into Fy is 415 into ASV 100.53 whole divided by 0.4 into 300. The spacing is 302.4. Okay, so the value of SB is 302.46. Okay, so it is 302.46 mm. So if we round this spacing, then it will be 300 mm center to center. So from the second criteria, we got the spacing as 300 mm. Okay, and third criteria is in no case spacing of stirrups SV should be taken as 300 mm center to center. And now least value of these three we should add up. So the first value is 250, second value is 300, third is also 300. So we will add up that 250 spacing. So we will add up the value of 250 spacing. So now what we can write here, we will write provide two-legged stirrups of so and so diameter about so and so spacing. So we will write over here provide two leg two leg 8 mm diameter stirrup about 250 mm center to center. So about 250 mm center to center. Okay. So this is our shear reinforcement. Why this shear reinforcement is required? Because our nominal stress, that is tau v, is greater than tau c. That is why we are in need to provide this shear reinforcement. Okay. So now after this, now we we should take the check for development length. Okay. There is no need to take the check for deflection in the case of beams, as it will be safe always. So now we are going to take the check for development length. This is our last check. So now the check for development length. So we need to take the check for development length. So first calculate the development length. So development length LD is equal to, what is the formula? 0.87 F, or I will write the formula first. Phi sigma S upon 4 tau BD is the formula. So you put the values. What is the value of phi? Phi is nothing but the bar diameter. What is the value of sigma S? Sigma S is 0.87 Fy. So it is 0.87 into Fy is 415 into phi is 8. Is it 8? Our bar diameter 8 is for stirrups. What is the bar diameter of our main steel? So bar diameter of our main steel is 20 mm. Okay. Whole divided by it is 4 into tau BD. What is the value of tau BD? The value of tau BD is 1.2, but in tension zone we need to increase the value by 60%. So multiply this by 1.6. Tau BD value is 1.2 for M20 concrete. Okay, if the grade of concrete is changed, then this value is also changed, and this value is given in IS code. I think in table number 20 or somewhere it is given. Okay. So now if you solve this, you will get the value of development length, LD. Let me know the value, 0.23. 940.23 mm. So this is the value for development length. Okay. Now to calculate the other side, that is 1.3 m1 upon mu plus L0, that we need to calculate. So first calculate the value of m1. Okay, so we know m1 is equal to mu by 2, which is equal to, what is the moment here? Whatever may be the moment here at the support, that moment we should take at here. Okay, so this mu is nothing but what is the moment at your support. Because development length we are going to calculate it as the support. So at the support our maximum negative moment, because the support hogging moment will be there, and the maximum moment is 152.31. It is divided by 2, so which is equal to, it is 76.15 kilonewton meter. Am I right? or we have got the different values. What is the value of mu? Please check the answer. Mu means maximum negative moment. What was our maximum negative moment? We have calculated now our maximum negative moment. 151.92. Okay. So it is 151.92. So accordingly we will get the values over here. So 151.92. So when you divide it by 2, what is 75.96. So the answer is 75.96 kilonewton. Now next is to calculate V1. The V1 म्हणजे काय असतं? V1 is the shear force at end support, because development length is always provided at the juncture of beam and column or beam and slab. Okay. So development length is always at the end support development length. So V1 is nothing but shear force at end support. So whatever we calculated the shear force earlier, that is nothing but it is the maximum shear force. Okay, so now if I show you here in the diagram, so again this is our diagram. So these are our supports. These are our supports. Now see, earlier VU which we have calculated, it is for this point 144.72 and 144.72. It is for these 2 points. Okay, that was the value of VU and that is the maximum value. Maximum value. Okay, for to designing the shear force. But the development length is always provided at the end support. Okay. Development length कुठे असणार आहे नेहमी? It is always at the end support. So now this is the point where development length is there. This is the point where development length is there. Okay. So for now the V1 value must be here. Whatever the value of shear force at this point, that value is nothing but V1, or whatever the shear force is at this point, this support, that value is nothing but V1. And this shear force we want to calculate now. Okay, V1. That is the shear force at the end support. Okay. So again we will calculate this shear force by taking the coefficients from IS code. Okay. So if you draw this diagram for your understanding, I have drawn it for your understanding. Okay, what is V1, what is V max, you should understood this. So now I will go to the IS code and we will move to the table number. What is our table number? Table number 12. So we will move to the मगाशी आपण 0.4b चा जो फॉर्म्युला वापरला होता ना स्पेसिंग काढताना, तो फॉर्म्युला इथे आहे बघा. क्लॉज नंबर 26.5.1.6 पेज नंबर 48 वरती आहे बघा. दुसरा क्लॉज स्पेसिंगचा काढायचा स्टिरअप्सचा. ओके, नाउ वी आर सर्चिंग पेज नंबर table number 12. This is table number 16. On page number 37, table number 12 is there. So I am going at page number 37. This is page number 37. This is page number 36. Okay. Now see, if you see over here on page number 36 again. So now this is as you know, this is for dead load. This is for live load. Now we want to calculate the shear force at end support. At end support, our shear force is V1. So the coefficient for dead load, this is 0.4, and the coefficient for live load, it is 0.45 at the end support. Okay. So our formula will become, it is V1 is equal to, it is 0.4 into WD into L effective plus it is 0.45 into WL UL into L effective. This is our formula for V1, that is shear force at end support. Previously we had taken these coefficients and these values are calculated at the end support next to the end support. Okay, these values are calculated at next to the end support. Are you getting my point? But development length is always at the end support. So V1 is nothing but the shear force at end support. And for end support, these are the coefficients zero point 0.4 and 0.45 that we need to consider. Okay, so now again coming back to our point. Now again coming back to our point. So so now here we want to calculate the value of V1. So I can write as per table number 12. Okay, page number 36, IS 456 2000. V1 is equal to zero point 0.4 is the coefficient for dead load. So WUD into L effective. This first bracket is for dead load plus this second bracket is for live load. Second bracket is for live load. Now just put the value and let me know the answer of V1. So the answer of V1 is 101.88. Please cross verify the answer. 0.4 into 22.2 into 6. This is your first bracket plus in the second bracket it is 0.45 into 18 into 6. So the answer is right, 101.88. So the value of V1 it is 101.88 kilonewton. This is the answer we got for the what we can say shear force. So now in the problem, if the width of support is given, then you should take the width of support as it is. Now if in the problem the width of support is not given, so we need to assume the width of the support. And okay, so to calculate L0 we need the width of the support. So if it is not given, then assume width of support, assume width of support is equal to how much? Assume it as a 230 mm. Okay, I am assuming it as a 230 mm. So now L0 is equal to what is the formula? It is width of support. The formula is width of support divided by width of support divided by 2, okay, minus clear cover. Width of support divided by 2 minus clear cover. This is the formula. Now therefore L0 is equal to the width of support, it is 230 divided by 2 minus clear cover is 30 mm. So solve this now, you will get the value of L0. Therefore L0 is equal to, so the value of L0 is 85 mm. So the value of L0 is 85 mm. Now put all these values in our formula, that is 1.3 m1 upon v1 plus L0. Okay, so now I will call this term as a LD1, okay, which is 1.3. तुम्ही काय म्हटलं नाही तरी चालतंय, मी जस्ट एक नोटेशन दिलेलं आहे, म्हणजे दरवेळेला फक्त एवढं लिहिण्यापेक्षा आय हॅव गिवन वन नोटेशन टू इट. So 1.3 m1 upon v1 plus L0. So our LD1 will be 1.3 into what was our M1 value? It is 75.96. Okay, so it is 75.96 into 10 raised to 6 whole divided by 101.88 into 10 raised to 3 plus L0 is 85. So LD1 4.25. So 1054.25 mm. Okay. So this is the value of LD1. Now here your LD is less than LD1. Hence it is safe. Okay. Hence it is safe. Hence it is safe. Now we will draw the cross section of the beam. Okay. Showing the reinforcement details. We will draw one cross section. So in the cross section now, first of all I will draw here this is the stirrups. Okay. Now again I will draw the beam. I will provide the bar. So at the top 3 bars of 20 mm. So we will provide 3 bars at the top. These are the 3 bars of 20 mm, and at bottom also 3 bars of 20 mm. Okay. So at top and bottom 3 bars of 20 mm, and this is 2-legged stirrup. So draw this reinforcement. So draw this reinforcement. So here these are our top reinforcement. So here what is the diameter? These are 3 bars of, these are the top bars, 3 bars of 20 mm diameter. These are the top bars. At bottom also 3 bars of 20 mm diameter at the bottom. And now the spacing, this is 2-legged stirrup. This is nothing but it is 2-legged 8 mm 8 mm diameter, about 250 mm center to center. So this is the reinforcement details, and here you can show the hook. Now what are the dimensions we have finalized? So this width, we have assumed this width as a 300, and this total depth of the section was 650. So this was 300 and this was 650. Okay, so draw this in detail. This is 300 mm. Okay, so this is the cross section of beam. Reinforcement cross section. Okay, I can write here, this is reinforcement cross section. So this is the final reinforcement which we have provided, and this reinforcement is repeated for all the spans. Okay, so we are going to repeat this reinforcement for all the spans. So this is the problem of this, what we can say, continuous beam. So here our first problem ends, and definitely this type of problem 100% it is there in your exam, and there is no any other variety in the case of this continuous beam. हा जो प्रॉब्लेम घेतला ना तुम्हाला आता, सेम टू सेम हाच प्रॉब्लेम तुम्हाला एक्झाम मध्ये पडणार. ओनली देर विल बी द चेंज इन द व्हॅल्यूज. ओके, ओनली देर इज change in the values. So the problem is very lengthy, but there is no any what we can say twisted questions on this topic. So there is only one type of question on this topic, and that question is design a continuous beam. Only the variation in that is that they may give you different spans. आता आपण जे 3 span continuous beam घेतलेली आहे ह्याच्यामध्ये मला सांगा स्पॅन किती आहे. द स्पॅन इज 6 मीटर. Okay, and that span is constant for every so first span is also 6 meter, second is also 6 meter, third is also 6 meter. But in the exam they can vary your span. So say that first span may be of 4 meter, second span may be of 6 meter, third span may be of 5 meter. Okay, this may be the dimensions. So in that case now you should do the design for maximum span. Which span is maximum, that span you need to consider for the design, and you design for the maximum span and provide the same design for the other span. Okay, as if you design the design it for the 6 meter span, then it will be automatically safe for 5 meter span. Okay, like this way you have to do the design. Okay, now take the next problem. So take the next problem now. I will again write the problem on the board. You copy down the problem. Okay. So if it is over now, I will switch to the next board, and now I will write the problem. So the next problem I am going to write, you also copy me. I will read the problem. Design a continuous reinforced concrete beam of a rectangular section to support a dead load of 12 kN per meter and a live load of 13 kN per meter over the span of the beam. Over the entire span of the beam असं पाहिजे. The entire word is missing over here. You add that word. Entire span of the beam. The ends are simply supported. Ends are simply supported. Add of 10-20 grade of concrete and Fe415. The beam is 4 span continuous beam with end spans of 4 meter and interior spans of 6 meter. So it is now 4 span continuous beam and its end spans are of 4 meter and the interior spans are 6 meter. Okay, so let me know if you finished the writing of the problem. We will move forward. So they have given us what they have given. They told us the dead load. Okay, so dead load is given. Dead load is equal to, what is the value of dead load? 12 kilonewton per meter. Then they give live load. What is the value of live load? Live load is 13 kilonewton per meter. Then FCK 20 MPa. Then FY 415 Newton per mm square. Okay. And now they told us, now this time 4 span continuous beam is there with different spans. Okay, so if we draw the beam now, if we draw the beam, it is now 4 span continuous beam. So this is the first span, this is second span, here it is third span, now this is fourth span. Okay, if you count, this is your first span, first, second, third and fourth. Okay, now if you count, This is your first span, this is second span, this is third span, and this is fourth span. Four span continuous beam is there. Now what they have told us, for the end span, okay, for end span, what is the length or what is the span at the end? At the end, the span is 3 meter. Okay, at the end, the span is 3 meter, and the span is different at the middle. Interior spans are different. Diagram. Okay. So now here the interior spans are of 6 meter. So this span is 6 meter. This is also 6 meter, and here this span is of 4 meter, and this span is also of 4 meter. This is the given problem to us. Say 4 meter, 6 meter, 6 meter, and 4 meter. Now dead load lecture चालू आहे झाल्यावर फोन करतो मी. So dead load 12 kilonewton per meter, live load 13 kilonewton per meter. Now here what we are going to do, we are going to adopt the same strategy, but the only thing is that while designing we are going to consider the 6 meter span now. We are not going to consider 4 meter span. We will design the structure for 6 meter, and whatever may be the reinforcement is there, we are going to provide it for 4 meter. Okay. So now we will start with the problem. So span to depth ratio in the case of continuous beam. So what is the span to depth ratio? It is span divided by d, which is equal to 10. Span to depth ratio is 10. Okay. So now d is equal to, what is the span? The span, take it as a 6000 divided by 10. So again you got the value d is equal to 600 mm. Okay. Again assume 30 mm clear cover and 20 mm bar diameter. So you will get the overall depth. So if you finish, then I will switch to the next one. If you are finished with this, let me know in the chat box or tell me by switching on your mic. Assume clear cover is equal to 30 mm and 20 mm bar diameter. So we have assumed 30 mm clear cover and 20 mm bar diameter. Okay. So your overall depth d is equal to, your overall depth d is equal to, what is your overall depth now? It is 600 plus 30 plus 20 by 2. So what is the depth? It is 640. Okay. The width of the section is not given. So I will assume the width of the section. Assume B is equal to, nothing is given, so I will assume this as a 300 mm. And also width of support is also not given. So I will assume width of support, it is also 230 mm. So we have assumed B, that is width of the section. So width of the section is 300 mm and width of support is 230 mm. That we have assumed. Just a minute. Huh? Hello. नहीं आए नहीं अभी तक. उनका नंबर लग नहीं रहा है. मैं कल से ट्राई कर रहा हूँ. मैं अभी लेक्चर में 15 मिनट में लेक्चर खत्म होता है. मैं दूसरा नंबर किसी के पास से लेके आपको भेजता हूँ. और दूसरी बात है, वो मेरे कंप्यूटर 2 ही सिस्टम कनेक्ट हो रहे हैं मेरे आईडी से, तीसरा नहीं हो रहा लेकिन इंटरनेट. हाँ करो अभी चलता है. हाँ मैं 15 मिनट के बाद भेजता हूँ. अभी लेक्चर में हूँ. हाँ. So now, we have assumed width of beam and width of support also. तो कोकरे सर लेक्चर घेऊ द्या की मला कंटिन्यू आवाज इथं चालला सगळ्याचा आवाज यायला लागलाय प्लीज सो नाउ width of beam is 300 mm and width of support is 230 mm. So after this we are going to do the load calculations. So the load calculations, so we will finish up to this one today. Now load calculations we will do and we will stop over here, and in the next lecture we will take the remaining part. So for the load calculations now, what is our overall size? Now our overall size of the section, it is 300 by 640 mm. This is our overall size of the section. Okay, 300 by 640 mm. This is our overall size of the section. Roll number 60. Please switch off your mic. Shubham. So now overall size is 300 by 640 mm. So we will calculate the self weight. Self weight is equal to, it is now 0.3 into 0.64 into 25. So fast do the calculation and let me know the answer. What is the self weight now? 4.8 kilonewton per meter. This analysis we are doing for per meter length. We have not considered here length. See, this is width, this is depth, but we have not multiplied here by length. So it is per meter length we got the load. So it is in kilonewton per meter. Okay. So now after this, we will calculate the total dead load. So now we know the dead load. Dead load is 12 kilonewton per meter. So total dead load now we will calculate. So total dead load is equal to, it is 4.8, it is self weight plus 12. So it will be 16.8 kilonewton per meter. This is your total dead load. So from the total dead load, we will calculate factored dead load. Factored, or this is nothing but ultimate dead load, which is equal to 1.5 into 16.8. What is the answer?
25.2.
Okay, so the answer is 25.2 kilonewton per meter. Similarly, total live load, it is given as 13 kilonewton per meter, and no any other live load is given. So the factored or ultimate live load is equal to, it is 1.5 into 13. Answer
19.5.
18 point
19.5.
okay 19.5. So the answer is 19.5 kilonewton per meter. So now this is the total dead load. We know the total live load. Okay. So our next job is, we have calculate ultimate, that is factored dead load and factored live load. Notations आपण याच्यासाठी काय वापरतो? Ultimate dead load म्हणजे याला आपण म्हणतो WU stands for ultimate and D stands for dead load, WUD, आणि याला आपण काय म्हणतो? WUL. Okay, ultimate live load. These are the notations for ultimate dead load and ultimate live load. And for total dead load, your notation will be WD only, dead load. And for total live load, your notation is WL. Okay, here so you will. Now after this, we are going to calculate the bending moment. Okay, so to calculate the bending moment now, again we need to do the same thing. For end span, we have to calculate the bending moment. After that, we have to calculate the bending moment, support to the next to end support, then at the interior span. So we are going to use the table number 12. on page number 36 to calculate the bending moment. From those tables we will get the bending moment coefficient, and we will multiply those coefficients by W into L, the WL square. So we will get the bending moment. Okay. So for that, now if I show you the diagram for this beam, okay, now if we draw the diagram, tentative bending moment diagram. Okay, if we show this diagram, so here is one support, here it is. Now four span continuous beam is there. So first span, second span, third span, and fourth span. Okay, so this is our four span continuous beam. And now if you draw the bending moment diagram, it will be similar to, at the support hugging moment will be there, and at the center sagging moment will be there. Okay, so now we can see that this moment is positive, this is negative moment, this moment is positive, this is hugging negative, sagging positive, hugging negative, sagging positive. Now again I will repeat you the points of the bending moment, so that in the tomorrow's lecture or the next lecture we will directly get the coefficient. So whatever may be the bending moment at this point, this is your point number 1. Same will be the bending moment at this point. This also I will call it as point number 1. Then whatever may be the bending moment occurred at this point, at the support next to end support, this is your end support. This is your end support, and this is the support which is next to end support. And same is this situation on the right hand side also. So if we call this as a point number 2, then whatever bending moment is generated here at point number 2, same bending moment will be there here at point number 2. Okay. Now the next point is, this is the positive bending moment here at this section. So whatever the positive bending moment here at this point, if I call this point as point number 3, same bending moment will be there at this point, and this is our point number 3. And last one, this is the only a single point, and this is our point number 4. Okay, our point number 4. So this point 1, so I will write down here what they called as a, now point 1. Point 1 is nothing but it is mid span of, or it is, we can say middle of, it is middle, this is the middle point, middle of end span. This is called as middle of end span. Point number 1 means middle of end span. Okay. Point number 2, this is at support, this is at support next to end support. Point number 2 is called as, okay, so instead of this, correct, point number 2 at support next to end support. Okay, this is called as point number 2. Then this is your point number 3, and this is at interior span, so middle of the interior span. So your point number 3, it is nothing but it is at middle of middle of interior span, middle of, so drop your roll number into the chat box and draw this diagram, middle of interior span, and also draw this diagram, this is also most important. So, and this is 4, okay. This is called as at interior support. So I have given the naming of all the 4 supports also. वन पॉइंट, सेकंड पॉइंट, थर्ड पॉइंट, फोर्थ पॉइंट कशाला काय म्हणतात आणि ह्याच्या खालीच आयएस कोड मध्ये कोएफिशियंट दिलेले आहेत. ओके, in the IS code also the coefficients are given in this way only. Understand the shape of bending moment and where we are going to calculate the bending moment. Okay, and what those points are named. So point number 1 means yeah, one point la म्हणतात middle of end span. Point number 2 is called as at support next to end support. Point number 3, so point number 3, this is called as middle of the interior span. And point number 4, this is called as at interior support. So these things you should know because in the IS code they have given the heading in this manner. Okay, if you open the IS code you will see the headings in this manner. So if you know how the profile is and where you are going to calculate the bending moment and what coefficients you are taking, then it will be easier for you, okay, for the understanding purpose. So now today it is sufficient, I think so. We will meet in our next